about a very important topic in physics, which is linear momentum. And this is the part 2 of this topic. So without wasting time, let's get to know what we'll be discussing in this very edition. We'll be talking about applications of linear momentum basically. We'll be focusing on gun explosion. We're talking about rocket propulsion. We'll be talking about body in a lift. These are the 3 main aspects or the 3 main applications of linear momentum. So without wasting time, let's look at the first, gun explosion. Now the formula that connects or that shows the linear momentum during a gun explosion scenario is this, where you have mvvb equals to mgvg. Okay, this is the formula to take note of under gun explosion. Now, what is mv? The mass of the bullet. What is vb? The velocity of the bullet, also called the muzzle velocity. What is mg? The mass of the gun. And what is vg? The velocity of the gun, also called the recoil velocity. So if you are not giving velocity of bullet, you can also be given as muzzle velocity. So you have to be able to tell which is which. Difference between muzzle velocity and recoil velocity. Now we know this. Let's quickly look at rocket propulsion. Now, there are 3 important formulas to be noted. The first formula is V equals V subscript E, ln, where your ln is natural logarithm. You have it on your higher functional scientific calculators, okay? Where you have V equals VE, ln bracket MI over MF. Now, MI here is the initial mass before the rocket was propelled, while MF is what final mass, okay, during the motion. Now, that is the first formula. F here is equals to VE times R. Now, each of these symbols or each of these variables have their meaning, okay? We'll look at them. And the last formula is for A, called acceleration. Now, A here is equals to VE times R over M. Now, what is V? V is called the burn out velocity. So if you ask to find the burn out velocity of a rocket that has so and so exhaust velocity, if the initial mass was given as whatever they will give it, and the final mass was given as whatever they will give it, this is the formula you use to get the what? The burn out velocity. Now if you ask to find the thrust or the force, okay, with which a rocket will be propelled, okay, this is the formula you use. Where the VE here stands for what? Exhaust velocity, also called the ejection velocity. And the R here is the mass of fuel burned per seconds. That is change in M over change in T. Mass of fuel burned per second, okay, time. And it's given as kilogram per second. This is a unit to know that it's for what? R. And lastly, A, which stands for acceleration. If we're not asked to find the acceleration of the rocket at a certain time, this is the formula to use. VE meaning what? Exhaust velocity, or you say what? Ejection velocity, times the rate, where the rate is talking about the mass of fuel burnt in a certain time, over what? The original mass of the what? The rocket itself. I hope this is clear, or the original mass of the fuel. Now this is the formula to use to get the what? Acceleration. So now we know this for rocket propulsion. Let's look at the formulas we must have in mind under weight of body in a lift. Now there are different scenarios, because if you have been in a lift before, it's either the lift is taking you upward or it's going downward, and there are other extra, so let's say uncommon cases too to be studied. Now the first case here is if the lift is at rest, or if the lift is moving with what? Uniform velocity. Observe I said uniform velocity, not acceleration. Now, to get the force that will be acting on the lift, because the lift is usually suspended by, let's just say a string, an inextensible string. Now, the force that will be acting on the lift, if the lift is not moving, or if it is moving with uniform velocity, is F equals to mg. And that's equivalent to the weight of the person inside. Is it not good? Now, if the lift is now moving upward with an acceleration, this is the formula to make use of. That acceleration will be added to the normal value for gravity, which is 10. Then you will multiply it with the mass of the person inside to get the force acting on the lift. Now, if the lift was moving downward with an acceleration, okay, this is is the formulas to use. Now, which are we going to use at a particular time since we have two of the formulas? You can use any, provided if the acceleration is bigger than the gravity, use this one. But if the gravity that was given is bigger than the acceleration, you will use this. So it depends on the question. If you were told a body in a lift is descending with an acceleration of, let's say, 12 meters per second square. 12 is bigger than the normal value for gravity, which is 10. So this is the formula to use. But they said a body is descending with an acceleration of 8 meters per second square. Because 8 is less than 10 meters per second square, which is the value for gravity, you will use this. I hope that is clear. Now lastly, if the lift, peradventure, the rope was cut and the lift starts free falling meaning that the acceleration acting on the lift is equivalent to 10, that is normal value for gravity. A is equals to G, and this was a JAM question if you were conscious of the question that was sent for 2025. Free fall is when the acceleration is equal to what? Gravity. I hope that is clear. Now because acceleration is equal to gravity, so A here is also what? G. So G minus G is what? 0. 0 times M will be what? 0. So there is no force acting on the lift as a whole whenever the lift is what? Free falling. And that scenario is called what? Weightlessness. I hope that is clear. Now, the F we have been talking about can be asked for in question. They can say find the force, or they can say find the tension acting on the lift, or they can say find the apparent weight. They are all referring to the F. I hope that is clear. So now we have all these formulas at the back of our mind. Without wasting time, guys, let's quickly get down to one or two questions under the part 2 of linear momentum. Let's have them now. Alright guys, these are the two questions we're asked to solve under linear momentum. So without wasting time, let's get started. For the first question, it reads, it said, a rocket burns fuel at the rate of 0.01 kilogram per second. Now this is rate and this is the unit, kilogram per second. So that's the first derivative. R is equal to 0.01 kg per second. Okay? Then moving on, they said, and eject it as a gas with a velocity of 5,000 meters per second. Eject velocity. This is the ejection velocity. So we'll come here and write VE equals what? 5,000 meters per second. Then what else? What force does the gas exert on the rocket? And this is F, unknown. Now, this is the question we are asked to solve under this topic. And this is specifically under rocket propulsion. Now go back to it and tell me what formula do you think contain arrow, VE and F at the same time? The answer is F equals VE times arrow. This is the formula I'll be making use of for this very question. Now ask yourself, we are going to be imputing now. Watch out. What is the value for VE? It's what? 5,000. 5,000 times. What is the value for what? R 0.01. Now observe that they are in their standard unit. That's why they don't convert. That's why I went straight to this very step. Is it not? Now if you times these two together, 5,000 times this will give you exactly 50. Now because we are asked to find the force, the unit is what? Newton. And this is the answer to the question. It's very, very easy. It's not difficult. So let's get straight to question 2. Solution. Now we'll be doing this together. Let's do it together. It reads, a body of mass 2 kg. This is a quantity in physics called mass. And it's what given as 2 kg. They said it's suspended from the ceiling of a lift. So this topic is what? Body in a lift. Is it not good? Now with a light inextensible string, that's the scenario being described. Then I said if the lift move upward, are you seeing that? With an acceleration. That is, the lift is what? Accelerated upward. Is it not? Now what is the acceleration? Acceleration is symbolized as A. The value for the acceleration they gave us is what? 2 meters per second squared. Is it not? Now this is what we have. They now said, calculate the value of or the magnitude of the tension in the string. And we know that tension under this topic is still represented as what? F. So F is unknown. Now they gave us in addition that take G as what? 10 meter per second square. So guys, this is what we have. Now ask yourself, for the scenario whereby the lift is accelerated upward, what is the formula to be used? The answer is F equals to M in brackets G plus A. And this is the formula we will be using here. Are you seeing that? So this is the formula to use, guys. Now watch out. Simply by imputing, what is our M? 2. Okay, 2 is our M. In brackets, what is our G? We're giving G as what? 10 plus what is our A? We're giving it as what? 2. So close the bracket. Now from here, observe what will happen. This will be 2 times 10 added to 2 is what is in the bracket. So let's work it out first. 10 added to 2 is what? 12. So you just simply put what? 12 here. Now if you times 2 with 12, you have 24. Now because what we're asked to find is tension, and tension is a form of force, it will still have a unit of what? Newton. And this is the answer to the question. I hope you clearly now understood how question under these three aspects, gun explosion, rocket propulsion, and boarding a lift are being solved. So back now, guys, I'll be giving you guys one question to try your answer on. Let's have the question now. Alright guys, here is the question you are asked to try your answer on. It reads, a gun of mass 2.5 kg fires a bullet of mass 0.02 kg with a muzzle velocity of 500 meters per second. Calculate the recoil velocity of the gun. Now you have the mass of the gun as mg. You have the mass of the bullet, okay, as mb. You have the muzzle velocity as what? vb, is it not? And then you are asked to find recoil velocity of the gun. That is what? vg. So do well to try your answer on this question and let me know what you think the answer is in the comment section. Don't forget to share my videos with your friends. Thanks for watching. I remain Pizza. See you in my next video.